Hi ladies and gentlemen, notes 7.2 are on 3D geometry day 2. Everything that we are doing here is review, but putting it all together is very tricky. So please make sure that you guys are paying attention and you rewatch things that may be confusing to you, okay? So question number 1 says to find the volume of a perfect sphere that has a radius of 9 times 10 to the 5th power units. So I'm going to zoom in a little bit right here just so we can kind of see, so we have some room to do our work. So you're going to have to write really small. So you should see the problem in front of you. You might not be able to see it that well right here, but it's written in front of you on your paper, so you should be good to go. So it says it's a sphere, so I'm going to draw a picture of my sphere right here. So here's my sphere, okay? And it says that the radius right here is 9 times 10 to the 5th power units, okay? So I'm going to use the formula for the volume of a sphere, and I'm going to underline this in pink so you can see what I'm going to plug in. So the formula for the volume of a sphere is 4/3 pi r cubed, and we know what the radius is. So I'm going to say V equals 4/3 pi times 9 times 10 to the 5th power raised all of it to the 3rd power. Okay, so now here's where things get tricky. Everything inside of here is being raised to the 3rd power. So the 9 is being raised to the 3rd power and the 10 to the 5th power is being raised to the 3rd power. So what this means is I have to figure out what 9 to the 3rd power is. Well, 9 to the 3rd power is just basically 9 times 9 times 9. Okay, so let's figure that out in our calculators. All right, so let's see, 9 times 9 times 9. Okay, which means that I end up getting 729. So 9 cubed right here ends up being 729. All right, so then let's copy this down. I get V equals 4/3 pi times, this becomes 729. But this 10 to the 5th power is also being raised to the 3rd power. So let's figure out what 10 to the 5th power is when you cube it. Well, remember, when you raise a power to power, you multiply your exponents. So this just becomes 10 to the 15th power. So it's 729 times 10 to the 15th power. All right, now remember, we have coefficients and we have our base with our exponent. This is our only base with our exponent. So this is going to stay as 10 to the 15th power for right now, okay? Now I have to figure out what this whole thing is right here. So I got to figure out what 4/3 times pi times 729 is. So let's go ahead and do that. What I'm going to do is I'm going to type in 4/3. Remember, this sign right here, this division sign right here, or this bar right here, means I'm going to divide. So it just means I'm going to take 4 divided by 3, okay? Multiply that by pi, okay, then multiply that by 729, okay? So I end up getting this big, large number, 3053.628, blah, 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 okay? So I'm going to write out a few digits of this number. So I get V equals, again, if you look at your calculator, you got 3053.628 times 10 to the 15th power. All right, so now we've done our multiplication of our coefficients. So this answer is almost there. By the way, let's actually erase this equal sign and let's make this approximately equal because we did some rounding, okay? So now here's the thing that you have to realize. This number is not between 1 and 10, so we're going to adjust it by moving this over 3 times. 1, 2, 3, right? So that's what we're going to do, move the decimal place over 3 times. So now it's 3.053628, right? And if this moved over, the decimal place moved over 3 times here, okay? So again, if the decimal moved over 3 times here, then that means that this number has to increase. If this goes down, then this should go up because it's a balance. So it's times 10. If this moved over 3 times, that means that you are putting the 3 tens that you're dividing out here in this section right here, so you're adding 3 tens in. So it's 10 to the 18th power, okay? And then lastly, if you look at the way your problem is written to begin with, it says find the volume of a radius, or of a sphere that has a radius of 9. So see how this is rounded to the nearest whole number, right? So that means our final answer, our coefficient, will also need to be rounded to the nearest whole number. So that means that the volume is approximately equal to 3. The digit that comes after a 3 is a 0, so I don't give the 3 a shove, right? Because it's not 5 and above. So it's 3 times 10 to the 18th power units cubed. All right, let's take a look at question number 2. Find the volume of a cylinder. So this time we've got a cylinder that has a radius of 4.7. So we know our radius is 4.7 and a height of 3.6. Excuse me, the radius is 4.7 times 10 to the 5th power, and the height is 3.6 times 10 to the 4th power. So let's go ahead and figure this out. All right, so again, you're going to want to write small so you can fit everything in. First thing I'm going to do is I'm going to draw a picture of what's going on. So right here, I've got my cylinder, okay, and I know my radius is equal to 4.7 times 10 to the 5th power, okay, and I know that my height is 3.6 times 10 to the 4th power. And since it's a cylinder, I can use the formula for the volume of a cylinder. And that formula is pi r squared h, okay? So I'm going to say V equals pi. Now I have to plug in, instead of r, I'm going to plug in my information, and that is that it's 4.7 times 10 to the 5th power, okay? And then I've got my height as well, which is 3.6 times 10 to the 4th power. All right, ladies and gentlemen, so now I have to follow order of operations, and I apologize, I missed something super important. This radius, 4.7 times 10 to the 5th power, has to be squared. So make sure that you have your squared right up here, okay? Make sure you've got squared in the corner up here. So let's go ahead and figure this out. So I need to figure out what 4.7 is when I square it, because everything inside of here is being squared. So 4.7 squared just means 4.7 times 4.7. Don't forget, you can use the 4.7 squared button, the squared button in your calculator. So if I type in 4.7, I can use this button right here, the one with the exponent of 2. There's my squared answer, okay? So I get 22.09. Okay, but then I also have to do this part right here, this 10 to the 5th power squared. So 10 to the 5th power squared, remember when you square things, or when you raise a power to a power, when they're both exponents, you multiply them. So this becomes 10 to the 10th power, okay? So I end up getting V equals pi, and then this 4.7 squared becomes 22.09, right? This 10 to the 5th power squared becomes 10 to the 10th, and then I can copy the rest of the problem down. So multiplied by 3.6 times 10 to the 4th power, okay? So next what I want to do is multiply all of my coefficients together. Pi is a coefficient because it's 3.1415926. It's an actual constant number. 22.09 is also a coefficient, and 3.6 is a coefficient. So what I'm going to do is I'm going to multiply all of those numbers together. So let's go ahead and do that. So I'm going to take pi right here, I'm going to multiply it by 22.09, and then I'm going to multiply that by 3.6, and so I end up getting that my volume is equal to 249.832. You can keep going and add more digits on, but it's not absolutely necessary, okay? And now here's the thing that you have to remember. When you're multiplying, what should you do with your exponents if they have the same base? So what do I do with the 10 and the 4? If you said you should add them, you're absolutely right. So it's times 10 to the 14th power, because 10 plus 4 is 14, okay? So now the last thing I need to do is adjust this, okay? And again, this should have been approximately equal to, because we did some rounding. So our volume here is approximately equal to, I have to move this decimal place over twice, right? So I end up getting 2.49832, And if this coefficient gets smaller, then my exponent here should get larger. So it's times 10 to the 16th power. The last thing I need to do is figure out where I'm going to round this number right here. So the place that you're going to round it is based on how the problem is given to you. So if you notice, the problem gives you both of these answers rounded to the nearest into the tenths place. So that means I'm going to round my answer to the nearest tenths right here. So I end up getting right here v equals 2.5. Because I look at the 4, that's my tenths place. I have a 9 after it, okay? So the 9 means that it's 5 and above, so I give the 4 a shove up to a 5. So it's 2.5 times 10 to the 16th power, and then I have no units, so I'm going to say cubic units is my answer right here, okay? All right, question number 3 says to find the combined volume. All right, so this time we're going to find the combined volume between two spheres. One that has a radius of 3.1 times 10 to the 4th power units, and another that has a radius of 6.7 times 10 to the 3rd power units. So what I'm going to do is I'm going to split my workspace up into 3 sections. My first section is going to be to find the volume of the first sphere. So we're going to call this volume 1. Okay, and then the second section is to find the volume of my second sphere. And then the third section is to find what it asks for, which is the combined volume. Okay, so I'm going to zoom in right here so I have some space to show my work. You're going to have to write even smaller because we have more work to show this time. Now I found some software that looks exactly like the calculator that we'll be using in class, so you can follow along a little bit more easily here. All right, so in our first figure, we have a sphere. So the formula is still going to be 4/3 pi r cubed, and it tells us that our radius is 3.1 times 10 to the 4th power. Okay, so let's plug in our information. So we get v equals 4/3 pi times 3.1 times 10 to the 4th power, but the radius needs to be cubed. So, just like we learned before, we got to cube the 3.1, so we got to figure out what 3.1 is when we cube it. So let's go to our calculators. Before we do anything in our calculators, you need to make sure that your mode, again, is in classic and not math print, okay? So if you go down here and press classic, enter, clear out of there, you can figure out what this value is right here. So now to figure this out, to the 3rd power means you just multiply 3.1 by itself 3 times. So I can just say 3.1 times 3.1 times 3.1. Okay, and then press enter and there's my answer. Or I could use this lovely little caret button, which is my exponent. So I could just say 3.1 caret 3, and that means this right here, 3.1 to the 3rd power. Press enter, you get 29.791. So this is 29.791. And then I also have to figure out what 10 to the 4th power is when I cube it. So 10 to the 4th power cubed, remember you just multiply your exponents, so you get 10 to the 12th power. So this whole thing right here ends up being b equals 4/3 pi times this number, this 29.791, times 10 to the 12th power. Okay, so let's just move this like that so you can see it a little bit better. Now remember, we multiply all of our coefficients. So 4/3 times pi times 29.791. So go back to our calculators, and don't forget right here that 4/3 just basically means 4 times 3, right? So right here I'm just going to do, 4/3 means 4 divided by 3. So I'm going to do 4 divided by 3 times pi times 29.791. And then I get that big, long, crazy decimal, so let's write this out. So I get v equals 124.788249, right? Times, I gotta bring this down, 10 to the 12th power. Now this number is too large, it's not between 1 and 10, so I'm gonna have to move my decimal place over twice. So I get v, and this again should be approximately equal to 1.247888249. If I move this over twice, this 12 should get 2 bigger, so it should become 14. So it's times 10 to the 14th power. And then I gotta make sure that my answer is written out how the problem was given. So the problem tells us right here that the radius is 3.1 times 10 to the 4th power. So this is written in with the tenths value. So right here, we're just gonna round this to the nearest tenths. So right here, this is my 10th place. Look at what comes after it. It's a 4, so that means that the 2 stays the same. So it's 1.2 times 10 to the 14th units cubed. That's the volume of my first sphere. All right, so now let's find the volume of the second sphere. So now we're going to do volume 2. And same thing, we have our sphere, okay? So here's our sphere. And we know that the radius in the second one, it tells us is 6.7 times 10 to the 3rd power. So let's go ahead and figure this all out. So I would say V equals 4/3, because it's a sphere. So it's 4/3 pi r cubed. And here the r is 6.7 times 10 to the 3rd power. So V equals 4/3 pi times 6.7 times 10 to the 3rd power, and I need to cube that value. So again, we have to we have to cube everything inside of here. So I have to figure out what 6.7 is when I cube it. So let's go ahead and figure out what that value is equal to by just simply typing in our calculator 6.7 raised to the 3rd power. So you end up getting 300.763. So that's what I'm going to write in right here. 300 points, let's move this over so you can see it a little bit better, 763. Okay? So that's what I end up getting for this value when I cube it. Now let's cube 10 to the 3rd power. So it's 10 to the 3rd power cubed. So that means I got to multiply these 3's together, so I get 10 to the 9th power. So I end up getting V equals 4/3 pi times 300.763 times 10 to the 9th power. Okay, now in my calculator, I'm going to multiply all of my coefficients together, so all of these values, and then I'm eventually going to have to do some rounding. So let's figure out what this is. So this right here says 4/3, so let me just move this over so you can see it a little bit better, both of them together. So I'm going to take 4 divided, let's clear this out so you can see this better, 4 divided by 3 times pi, right? Isn't that what it says right here? 4 divided by 3 times pi, times 300.763. And I'm not multiplying by the 10 to the 9th power because that's not part of my coefficients. And I get approximately 1259.833,108, and it's approximately because remember this keeps going on forever, but your calculator rounded the answer, times 10 to the 9th power. Okay, so then I have to do my adjusting. So this becomes, move this over 3 times, 1.259833108. Since I moved it over 3 times, this 9 should become a 12 because 9 plus 3 is 12. And then same thing, your answer, the radius was given in tenths, so our answer needs to be written out in tenths. So here's my my tenths digit. What comes after it is a 5 and above, give it a shove. So you get 1.3 times 10 to the 12th power units cubed. Okay, so now the last part. It asks us to figure out what the combined volume is. So I'm going to take both of my volumes, my volume from the first answer, and if you look right here, our volume from the first one, let's zoom out a little bit for this. Let's make this 200%. So our first volume, maybe even 100% would be better. Let's try this. Our first volume was 1.2 times 10 to the 14th power. So I'm going to take 1.2 times 10 to the 14th power, right? And then it says that my new volume is 1.3 times 10 to the 12th power. So I'm going to take those two values and I'm going to add them together. So I'm going to add 1.2 times 10 to the 14th power plus 1.3 times 10 to the 12th power. So let's go ahead and do that. and see what this ends up looking like, okay? So let's write this out properly. 1.2 times 10 to the 14th power plus 1.3 times 10 to the 12th power. Now let's see if you guys remember what you're supposed to do when you guys are adding numbers in scientific notation. Our exponents have to be the same. They have to be like terms. So what I'm going to do is I'm going to make this smaller. I'm going to make this 10 to the 12th power. So that way this will match up with this exponent right here. So if this gets smaller, that means that I got to move this decimal place over twice. So if I move it over twice, I end up getting 120. This number is equivalent to this number. Remember, if I were to adjust this over twice this way, this would become a 14. Now they have the same exponent. So it's 120 times 10 to the 12th power plus 1.3 times 10 to the 12th power. Now and only now, because their exponents are the same, right? So this now works. It didn't work before because the exponents were different. Now they're the same. I'm allowed to add my coefficients. So I'm allowed to add 120 and 1.3 together. So I end up getting 121.3 times 10 to the 12th power. However, this number is too large, so I gotta adjust it. So I move this over twice. So it becomes 1.213 times 10 to the 14th power, right? Because if I move this over twice, I add 2 to this number right here. And then to the nearest tenths, you get 1.2 times 10 to the 14th power units cubed. Now, if you notice, hopefully you realize this, if you were to look at this right here, that's the exact same answer that we got for the original volume right here. But because this is to the 14th power and this is to the 12th power, this number is way bigger than the other number, right? So imagine like taking an ocean and adding a drop to it. What happens to the volume of the ocean? It basically stays the same. It's not, the drop isn't going to make a huge difference in the volume. Same thing right here. Because this number is way bigger than this one, it ends up being basically the same answer. So this right here is your combined volume. Make sure to come to me with questions if you have any. All right, have a great day.